Good evening, folks. Yeah, still catching up. I think we've been trying to get some answers out of the Gas City Oracle, and I think it did come back. It gave us some it said sort of like we asked too many questions at once. It could do some factual questions, but then it refused to answer some of our architecture questions. Even though we kind of are looking for facts that have a bearing on those architecture questions, but no matter. We can kind of clarify that later. And then the mayor queued up some design questions for us. So if you recall, that looked kind of like, let's see, right about. We and then the mayor onboarded a new department for us related to like front end UI, and it sort of improvised that, and then I pointed out it has a formula, and we tried to do some gap analysis there. And then we can talk through these design questions. These are the 4 design questions that we're starting to get into. Singleton agents versus pool of agents. How should lessons flow back to a department knowledge base? Ideally, part of the working of every workflow is sort of like a lessons learned, what went right, what went wrong kind of thing. If there's anything to add to the notes, then this is sort of when that should happen. What should we do for knowledge-based concurrency? I left an answer to this right at the end, and then pool sizing live in agent TOML or a city-wide surface. I think this is a sort of odd question. It has to do with where are scaling decisions made? Are they made sort of at a kind of you could say like a city budget sort of framework? Or are we talking about something more like an individual team trying to get its work done? And it's an interesting question now because in a human organization, you don't usually get to make the decisions, and the amount of resourcing that you have in the engineering staff is very slow to change. You can kind of pull from other teams in an emergency, but it's a very zero-sum game. Like if I'm working on your initiative, I'm not working on their initiative, kind of thing. But in this environment, that's not exactly true. We're more constrained by the resources on this VM than we are by, um, you know, how many agents we really want to have running, I guess. And so it does feel like a global sort of thing for this VM. But if you had access to unlimited VMs or functionally unlimited VMs, like say you could just spin up a whole bunch of agents for your problem, scale them up depending on the size of the work queue, and scale them down depending on the size of the work queue. That would be a way to do it. You could decide to pay for that. You could decide to have a maximum pool size to cap your costs. So there's lots of things you can think about. If you're very insensitive to TCO, you could just go, yeah, scale up until my job is done. Um, you know, shrink that queue, do the work as fast as you can, parallelize as much as possible, and then shrink back down, put all the agents back to sleep, or let them go away until they're needed to be called on again. I think this is for this particular city resident on this particular VM. We're probably going to talk about citywide services and monitoring the resources of the VM. Okay, so last we left, I left this answer about the different knowledge bases we're making and the limitations of our fileback system, and I haven't seen what it's done since, so let's go back. Okay. Maybe a pending question to GC Oracle is going to refine this. Knowledge base steps per slug and per instance files. There's natural sharding, right? Because 2 agents on 2 different games, puzzle types, aren't working on the same file. True. Per department append only notes. Correct. We could interleave rights. We're not enforcing anything. The department-wide index files are rarely updated. And so if we had two people updating sources at the same time, or the schema or the taxonomy, yeah, I think so. I think I agree with these different things, different assessments of risk, pros of staying file backed, greppable, etc. No new infrastructure. No transactions. Lock files. Yeah, underwhelming. Dolt. Ah, okay. Keep files, but fix these two hotspots cheaply. Okay, so I kind of like this. Add session IDs for session shards. Great. Agree on the right risks in our three current use cases. Per department logs are appealing. At the session grain are appealing. Once again, we might get back to the benefits of natural sharding. Natural sharding. One other thing we haven't been doing done much is to make this rig backed by Git repository. If so, we might start a merge queue and fix merge conflicts in that context. I believe this is already done in larger projects backed by Gas City. Let's see if we have our GC Oracle answers. Let's see if we have our GC Oracle answers. If they would change our opinions on sensible defaults. Okay. Let it cook a little bit. Oh yeah, Osanowa. Right, we were kind of explaining how we can just try all of the possibilities. It's gonna start looking kind of boring, I think, but 2 would go right here. we have two threes, and it's the difference between this is 1 and 1 makes 2. We can see that 3 would be 0, 4 would be 2, 5 would be 4. 6 would also work, right? 2 or 6. I forget what the rule is that constrains us. Write a number that is equal to the sum of the differences between the number itself and the numbers in the orthogonally adjacent cells. So, riddle me that. Why doesn't 6 work right there? I totally think it does. 6 minus 3 is 3. 6 minus 3 is 3. 6. If so, I mean, this kind of puzzle loses its savor a little bit for me if it doesn't actually have a canonical answer. The fact that we'll have to chain a number of numbers together to get out to in between these is kind of interesting. Like, I can kind of explain that. Say that we had a 1 here. That would imply that the difference here, well, that wouldn't work. The difference between these two is already 2, and they're the absolute value of differences, so we've already blown out our number. We could have a 3 here. That would make this number up here 6, right? Because 3 minus 3 is 0, and 6 minus 3 is 3, right? That would be the number. Can we have a 2 here? That would be a difference of 1 needed. Difference of 1, so 2, 3, right? Can you have a 4 here? A difference of 1, and then we need another difference of 3. It could be either 1 or 7, right? I guess this one could also be 0. And presumably it would just keep going on like that, right? But then we need to come over again and use that number right here. And now we need to satisfy a few different equations, right? I got to tell you, I don't think I'm enjoying this puzzle very much. It's like Sudoku that has lots and lots of possibilities in it, and yeah, the math isn't fun. This is probably the first Nikori puzzle I've really disliked. So those are really the only, yeah. Those are really the only rules, I think. There doesn't seem to be any law that we keep it to 6 or below. I mean, the puzzle is happening on a 5x6 area, but yeah. I'm going to leave this one behind. Roku. Block, I guess. Burok. Pazuru. Burok pazuru. Pazuru. Okay. Divide the grid of size n by n along the grid lines in n regions containing n cells each. A region must not contain 2 cells with the same letter. Oh, okay, cool. So we have to make sure there's exactly 6 and they'd be all unique in this. Okay, this will be fine. The symbols don't matter. It could be 6 of anything, 6 emojis, that kind of thing. All right. It keeps saying that my points are strong. Strong, sharp. That's my. You're absolutely right. Try not to think about it too much. Okay. They have little X's here too. I think that means no wall can be placed there. So these are like a package deal. All right, let's see what that tells us. D and B are a package deal. Obviously, any copies that are next to each other, like two B's like this, they've actually just drawn in exactly those ones, I think, so we don't even have to look at them. And yeah, I don't think it was inevitable that we go this way. That's why the X is there, maybe, to force us to take this direction. Like, there's two ways to think about this kind of puzzle. One way is to think I'm growing the regions, and the other one is to think I'm drawing the borders. You know? So we saw that when we were doing like Palisade. Okay. So one thing about linking C and D, right, is that they can't both go to one F, so we'd have to draw another line here and here. We're kind of looking for places that would cause a contradiction, right? So like this F is going to be with one of these E's, and then it has to kind of dodge around the other ones. It might not, there's enough to go around exactly once, right? The other thing that we're sort of dealing with is that they all have to be contiguous, right? And so if we ever try to draw something where we would cause two regions to happen that might have all the letters between them in a bag, but they're the sets aren't contiguous, I guess. I'll give you an example. Say that we had like these 5 right here, A, C, F, E, D. If we selected those as our set, then you can notice that there are actually no adjacent B's. So we can be sure that that's not the set. That's not the 5. There has to be a wall somewhere in there among these 5. That's interesting over in this corner because the thing that's missing over here is an F, right? We have to be able to get out to an F. If we took these 5 along the top, we'd be looking for a D and we don't see it. So that's kind of interesting as well. If we take this A, then we have to work around this A and E combination. I'm trying to figure out what's the best way to start a hypothesis going to draw something new. If we drew an X here, we'd have to draw a wall here because we couldn't draw another X here. Well, not only do we have to just keep extending the wall, but also if we didn't have a wall, then we'd have 2B in the same group. So let's try that for a minute. We only have sort of 2 worlds going in this puzzle. There's sort of a world on this side, and then there's a world on that side where maybe we don't draw the wall or we do draw the wall. So it's a little hard to do this sort of nomenclature. But in the world where we draw the X, we draw the wall. And then we have to continue the wall around like so. And most of our decisions have been made, right? We have to do this, this, this. We have to avoid this. We have to take this F. And then finally, we need an E to round out our set, and there it is. That would be a way to do it. If we didn't do this, or if we didn't do this X, if we cut this off, for instance, then it would look more like, I guess since there's only one way out, we'd actually be stuck with this set again. So this is kind of interesting, actually. So if we walled this off, right, these would all be stuck in this corner together. There's no way to get two sets going out of here. We have to continue this wall somehow. So we would go take these four together. In the other world, we would have this one again, still, this one, and this one. Oh, but that world doesn't work. And the reason why is that in this world we have to wall off this one, and then we'd have 5 letters that all be stuck this way, and then we would have to take our 6th letter as C. That's the only one remaining. But since we can't do that, the red world is actually correct. Yeah, and this is actually how we had to do it. So yeah, I would definitely prefer like a sort of scratch pad kind of a way to represent that I'm just trying hypotheses instead of actually permanently writing on the puzzle. But yeah, I think that sort of constrained area was sort of a good way to kick off the puzzle. We can't link these two sets together starting CBE because we'd have 2B. So this goes together. I'm using those little marks to make the groups hang together. C, B, E, F. Again, we can't be here. There's only one way to go, D. And our final letter has to be an A. And there it is. So there's only one way to do that after we figured out that bottom corner. FDB, we have to go to E, and we have to block off this D. Not only continuing the wall, but also to avoid the duplicate. We've got this C, and then we've got one last A. We can't take this one, though, because it's joined at the hip to an E. That would put 7 in our little group. Here we go. Let's return to this one over here, BDAC. We can't take another D or the B that's tagged to it. So we're left with this, and we got to take this E. Finally, we've got to split these last two groups together. Well, I'll just call this the group on the right. We've got the E and the A. They're together, and they're kind of trapping the C and the D together, too. We don't know if we're taking this B, except that we know that the other pair is B and D. So on the left, the B and D are accounted for, and on the right, we need the B. That'll be right here. So, okay. So that's the whole puzzle. The hypothesis testing that happened down here, like, can we take this, or can we, like, wall it off? That was the big break in the puzzle. And after that, we were basically mopping up. I don't know about this one. It's like, maybe it could get more complicated with more blocks. And certainly, like, hypothesis testing is not, I think, the most fun thing to do in a puzzle. All right. There isn't a scale department formula. It's per agent. There's no citywide knob. We would have to set it. Each department opts into pooling. That's okay. There is a merge queue. First class conflicts. So, and then here's all of the yeah, incremental becomes a repo. Um, so some of this get back stuff we haven't really been doing much. It's a private project, not anyone can join. Yes, but and part of that's just you know, I think that there's a safety in not trying to put sensitive stuff. Let's see. On camera, as well as like also thinking about, if I actually do want to make this into a product, how much of the underlying code do I want to expose? Like, it's true. Anybody who watched my videos and typed the things I typed, and you'd probably get much the same um, solution that I did. But that's sort of a pain. Go do your own thing. Don't just do my thing. But here, let's see. Hmm. We've got lots of random repositories. Um, hmm. All right. Um, all right. Um, let's see. I made a Git repo that could be used. Um, I also suggest that we want to learn about the gas town pack for Gas City. I haven't talked about this much, but the basic, the genesis of Gas City, right, was that our guy Steve Yegi made his own orchestrator, and had tried several times, and finally um, went back and forth and got this sort of design for the city. And Gas City borrows some of the patterns from that in a sort of generic way, like a mayor of the city that you talk to, fields of agents, sort of monitors that go through and make sure that everything's working properly, making sure that everybody's awake, that everybody who's got work is doing work. And some of the procedures and things that are inside of that city are, you could say, kind of memorialized, or codified in a sort of plugin style. So Gas City has packs. My understanding is that it has a merge view pattern. And there is a named worker that runs it. Engineer. What is the best way for us to research the ins and outs of such plugin packs? The BC Oracle might know. I'm in favor of starting a Git repo that the agents can scribble in, also so that the VM dying doesn't erase all our work. Mm-hmm. While we're looking at that, maybe I'll do my own sort of spelunking in Gas City, and we might be able to find the Gastown pack. Try again in a few minutes. Well, that stinks. We can just look locally. You know, everything's going to be fine. We just synced our branch earlier. Oh, I keep forgetting to make my aliases file. Now you're gonna see me not remember stuff. Is this it? Positional parameters, $1 and 2. I think this is how you do this in Bash. Maybe you don't have to put function at all. Okay, and then we can source aliases. Okay. Examples. Gastown. Just for my. Okay. Cool. So in the Gastown pack, we've got is that what it's called? Refinery? I forgot what it was called. But yeah, maybe refinery patrol. The refinery agent? Sure. Interesting. Okay. Uh, okay. Gas City provides flock and atomic right only for files that it owns. We Gastown pack itself exists locally. Oh no. Okay. Um. All right. I made it at. But didn't initialize it locally. Um. I was a little ambiguous. There is a Gastown source. Um, there is Gastown source in Gastown, but that's for a different predecessor project to Gas City. There is a hack that it's not simulates, mimics, reproduces some of its behaviors in Gastown. And there are docs on Pack V2. And again, we probably want to start looking at that because a lot of the stuff that we have been doing is kind of pack-like. We've been adding this feature that extends all of our agents, that kind of thing. And there's a lot of instances of Gastown still in all of this internal stuff inside of Gas City, right? Archived stuff, integration tests, hack stuff. I think the main place to look for it is examples, and then docs pack v2. Pack v2. We could ask GC Oracle about that. Since it's in the project. All right. There we go. I don't know why it's having trouble. This sort of stuff looks kind of like Claude having problems. Not the best time for it, obviously, but all right. While we wait, let's give him a minute. Yeah, I don't know about this one. Uh, Maybe it was just the example, but it didn't feel like we were making inference after inference. Felt like we were, exercising our brains really hard, and then we weren't. Chiyotsui. Blacken some cells of the grid, or color the gray cells of the grid either black or white. Black cells must form black areas that span exactly two regions and are symmetrical with respect to the border. So, like in their example, this one is mirror image across the border. Numbered area says how many cells will be blackened. So we could kind of know that if we were going to do 3 here, then it couldn't be mirrored across this border or this border, which only had 2 or only had 1. It would have to be across this. That could tell us some stuff. In an area without a number, it's unspecified. Black areas may not be orthogonally adjacent. Oh, okay, so once you have finished making a flipped area, this is one area, and they can touch at diagonals, but not on other faces. Okay, looks fine. Let's see how to do the inferences. That's another interesting thing about this genre, I think. Like, even if we see that this is the solution, we haven't necessarily learned how, and so all the fun of the puzzle is still waiting to be had. Not looking good. 529. I don't think that's from us. I think that's probably everybody. Shall we? Um, yep, elevated error rates primarily on 4.7. 24 minutes, so that would cover the current time period, I think. Well, I don't know. -7, that would be 940. Yeah, definitely still have that. So 9:15, they're investigating something. 9:40 Pacific, where I'm at. Yeah. Okay. Let's do one puzzle. We'll try again. And if we're not back, then we'll cut the stream. Okay, so as I mentioned, we're going to have 3 in here, and we can notice, hey, we're not going to mirror this across to here. Well, let me amend that a little bit. Because we knew we were going to have 3 blackened cells, but we didn't know that, they would all be contiguous, right? But think about what happens if this is blackened and this and this. This would get mirrored across like so, and then this would get mirrored across here. It would cause us problems, right? There's nowhere that we could put this. We would get a sort of, this would be the only way to do it. We have this weird orthogonal region. This isn't mirrored across the line. Let's see. The black cells must form black areas that span exactly 2 regions. So we'd violate rule number 2 here. So we definitely couldn't put 2 cells like so and mirror them over to here. So let's go way back. So for instance, all right. So let's try and gain some ground here. Figure out where to do. Uh, well, we can start with this one. It's kind of the simplest, right? Because it's very binary. There's a world where we shade this one across to here. Then we eliminate this square. Or we shade it this one, and it's going to go either here or here. Those are basically the only choices. Let's try this one first. We would have this one. That would be our flipped region. This wouldn't be, and this wouldn't be. We definitely couldn't do these three because there's no region border to flip them across, right? It's sort of ambiguous, but it seems like you would have to color in here, here, and here if you had these three. And we also couldn't flip these three down because that would span 3 regions. So we would definitely shade this one. The only border that it can flip across is right here. And we don't really know yet. Well, I guess we do know. If we have to flip across this border, then we would have to do these two, as we wouldn't be able to flip this one across that border. And I realize this is kind of what's already in the sample that we could see, but and then we have to do stuff like this so that we surround that region. If this one is to flip across any border, then it's got to come down here to the edge. And remember, this isn't all true. It's all hypothesis starting from shading this square right here. Here we go. Span exactly 2 regions. We have this one. All right. Like so. We wouldn't be able to flip across this border, and then we wouldn't be able to flip across this border. So we'd be left with 2 possibilities. Sort of like this, leaving out this one. It kind of doesn't work because we flip across this border, and then we'd have to flip across like this border. it doesn't work. We'd have to go this way and across this border. And we have to go this way. So we can't do it across a 3rd region. I think this would be the only way to do it. Okay, so let's call that scenario 1. Let's load back. I think this is probably the one that it does obey all of the restrictions, I think, and it's probably the one, yeah, this is the one that they had in the sample. Let's try and see what we can make of scenario 2. Scenario 2 looks like this. Including this one. And it has to either go across this way or this way. Let's try this scenario over here where we fill in this one. And we would exclude, here, let's, this means fill in, okay? This means exclude. We definitely couldn't use this one. We'd be forced into a scenario where we have to go like so, and like so. Yeah, so you can kind of see that this scenario wouldn't work. So we'd be forced then into this one. This. Or maybe we can just, there. This will make slightly more sense. Let's see where we can take it from here. Is this so bad? I mean, I think we are left with certain problems, like how to create a mirror image of this 3 that can go anywhere but right here. Right, so we certainly can't do all 3 of these. If we do this one, it has to mirror image over to here. But then we couldn't put in the next door neighbor, and we couldn't have this one flip over that same border. So we would have to be forced to color this one and this one. And then they have nowhere to flip to, either down or across. It makes 3 regions or off the grid. So we're forced not to use this one. And by consequence, this is not going to get filled in. We can't do all 3 of these. So just like before in our solution, we'd have this to contend with. Yeah, if you see another way to get this involved, then I didn't see another way to like break it up into 2 groups or anything like that. So we do much the same inferences now, I think. A lot of this. But we're probably going to run into difficulty because we didn't leave enough room over here. We need to put the one somewhere it can reflect. That's here. We need to make this not touch because it's not reflecting over that line. That would be down here. And now we have this conundrum where we don't have anywhere to make the reflections happen without, yeah, basically we'd have to make a reflection through here, through one across this line, across one of these 2 lines, right? But any way that we can do that, we're forced to make a blob that's more than 2 regions wide. So, I don't know how I would have notated this if I were just solving it by hand. Let's check on this. It looks like they're still out, but we'll try one more time. It does say it's thinking. Who knows? One more puzzle. I've been burned before. Chokona. Okay, so much like the previous one, blacken sum, how many cells? Block cells must form rectangular areas, and the rectangular areas must not touch orthogonally. Diagonally is okay. Okay. Okona. Oh, I see. This is the German name, probably. I've never really learned to speak German. I had one time where I went and I started reading Grimm's fairy tales in German at the library with my mom. We had a good time with that. We were like, oh yeah, Königsdochter. I think that I understand that's the king's daughter. That's the because the very first story, right, is the princess and the frog. The Frog Prince. So is that the actual title? Okay, it actually does seem to be doing some work. We could go read the question that it's creating. I sort of trust it at this level to faithfully transmit the contents of our conversation. So we still got this slung nudged thing, but I guess that's a named versus pool kind of thing too. We're gonna work all this out sooner or later. I think that this is kind of nice because it is taking us a little bit into the documentation. Even though there's no tutorial on this anymore, like our choices are kind of to go read the internals documents or to, you know, have our mayor and our specialist go read them for us. Okay. Yeah, why can't they all be like ice barns? I tell you what. Okay, right. We've got to color in some chocolate. Um, well, it's got to be brown, doesn't it? Hmm. This is milk chocolate, I would say. uh, we definitely can't have anything in there or there or there. A 1 by 1 square is a vacuously it's a rectangle. Um, this is an interesting spot because if we left out this one and colored in these four, we just can never make a rectangle out of that. So we've got to do that. If we left out this one and colored in these three, that couldn't be a rectangle either. Hmm. If we left out this one and colored in these three, they could be rectangles. They form 1 by 1 rectangles. So it's a little bit different for those. And similarly, this one. It's not impossible that we could want to color in all of these. Like this weird chunk, right? It's not usually as cut and dried like if you have to color in most of the squares. Even if we went around the corner here, we could fix it on the nearby region. these guys can push. It's fine. This is their scratch pad. They've been doing all the coding. It's all right. Is that true? It isn't. I thought that we were putting notes inside of the agents um, directories. So, like for instance, no, maybe not. Interesting. That's our knowledge base right now. It's sort of fragile and precious, right? Sure, you guys can go ahead and push. Um, well, it's kind of frustrating. Uh, because I guess what's frustrating about it is that I would like uh, all of the files for that are specific to this rig to be inside of that inside of the rig itself. Um, hold on a second. Okay. Um, actually, I noticed it's again, it's like see how all of the agents are up at the city level? All their stuff needs to be up at the city level too, right? But a lot of these guys are really specific to the rig. uh, in another rig, I wouldn't use them. They shouldn't have those jobs. Uh, and it's sort of like, hmm, maybe just the way that I'm thinking about this is just grinding against the sort of foundation of Gas City a little bit. And because I think the idea is that many agents specialized in generic tasks can do work on multiple projects, and it sure seems like we should have rig level agents, don't you think? And sub rig level agents and sub rig level departments and rigs inside of rigs, however you want to slice it. And that's not the grain that this is written at, right? It's written for like a certain mental model and use case. Like it's great to have people work across projects. I'm an agent. I'm not stuck working on my project. I can go to an adjacent project if I want to, if I'll be useful over there. Um, I guess I'm thinking about, we talked about this, I don't know, several videos ago, about being matrixed, about taking a functional job like engineering or a product area, like, you know, playtesting, you know, two really different things. Uh, well, I think that's okay. Yeah. Yes, file a bead to track. I don't have a great solution for this at the moment. It seems like we are both designing a city level pack with departments and routing, and at the same time creating rig specific agents with knowledge and specialization workflows. Maybe the right long-term move will be to create and submit our city level stuff as a pack. With a pack. And define the agents as a separate pack that is specific to a project, and then have them stored separately. I think as we work and learn about GC, the factoring will be more clear. Yep. So like right now, I'm not trying to, yeah, great. I'm not trying to have them do anything special with this. Probably nice that they are, they just have a safe place to work. Cool. I guess the bead will include my musings. Yeah, it's not super clean. Let's when it starts talking about this when we resume stuff, I tend to go, okay. I mean, we're at 25% of the context. That doesn't seem too bad. We don't have to use Gmail, Google Calendar, Google Drive. We haven't defined skills for all of our agents. It's unclear yet if we need any of that stuff. We've got some more Oracle stuff. Waiting. Now that we have a get backed rig, we might consider the definition of done for our agents when potential definition is to merge to the repository. I'm hoping we will learn from the Oracle about the merge queue. But there isn't a mechanism to regularly push the repository. Take advantage of branching, Git branching work trees, or other such collaboration features. Oh yeah, we were doing fine on this puzzle, I think. So one interesting observation we can make about this too, which is that if we color in this one, we have to color in the other one, because otherwise we'll create a little notch in this permanently, and there's no way to fill it in. It won't be a rectangle. So if this one, then this one, and not these two. And the same for up here. If this one, then we have to do this one, not these two. But if not either of those, then we have to be over here. If we're over here, then we have to move this into the corner. If we are not over here, then it could be right here. It would actually be underspecified. This is one of those inferences I don't like to use in the puzzle, which is like, is there more than one solution? Because we could infer things from that, right? Like, if we're like, oh, okay, this chocolate's over here, these are blank, and it's underspecified whether we fill in this one by one or this one by one right here, that means that the puzzle has multiple solutions. And if we're forced to avoid that by putting the chocolate right here, for instance, and then putting the chocolate in the corner, right, then we have gleaned something from the fact that the solution is must be unique. And again, that's kind of a weird inference. It's nice that it is unique, but it's not nice that we needed to know that to solve the puzzle. Here's a sort of different case. Imagine that we had the chocolate right here. There's only 3 ways to put the 2 remaining pieces. We could have a hole here and fill in these 2, which is not a rectangle. We could have the hole here and fill in these 2, which would make this C shape, and that's not a rectangle. We could have the hole here and make this C shape, and that's not a rectangle. So we can't do this one. It's got to be right here. All right. I wonder if we can apply the same logic here. If we filled in this one right here, then we definitely couldn't do these 2. That would make an S shape. Could do these 2. They'd just meet a triangle, and this would be a square. And we couldn't do these 2 because we'd make this knee shape. Yeah, if we did this, it would definitely have to be this would cause these 2. Let's look at, oh, well, we can just also do, if we color in these, we'll create a notch. So it can't be both of these. So it has to be this one. And then we can't color in this one. That would create that notch. Okay, there we go. It's possible that the chocolate could go here or here or here still. Still no change for this two or being this column or this column. It's compatible with both. There's a possibility we could have a big 3x3 square down here. I don't think there are any rules about it crossing multiple regions. All right. Mm-hmm. Let's mm-hmm. We can wait for the oracle to respond. Might want to nudge it. There was a partial outage recently. Not trying to look at the solution. I really just want to be inspired by whatever we can come up with. All right. So in the world where we don't fill in this one, we'd have 3 right here, and we just have to fill in this one. We couldn't fill in this one. We couldn't fill in these 2. We'd have to fill in this one and this one. Yeah, so if we did these 3, we'd have to keep going up this way. Then the chocolate here would have to be sideways, either attaching to that bar or separate from it. Separate from it. The kind of inferences we have to do here are kind of squirrely and hard to keep track of. Like, can I do this gigantic checkerboard pattern? And it kind of breaks down here. Like, say that there was a checkerboard for this 3 here, here, and here. They're all rectangles. But then I need to start extending that over here. And I run into some difficulties, like maybe I have to color all these in as chocolate. Whatever chocolate bar comes off of here can only be 1 wide. If I do fill in this one, I have to fill in these 2. If I fill in this one, I have to fill in this one. If I don't fill in this one, I can't fill in this one. So these 2 are kind of together either way. That's kind of interesting. Similarly right here, these are kind of together either way. We were making that kind of observation before, together. It's easiest to do that kind of at the borders, right? Like if this one is filled in, then they're definitely filled in together. You can't extend that out to here because if they're not filled in, then all bets are off on the next column. Same with this one. We're not sure if these are linked because we don't know if this right column, the second column, is happening. hopefully that's all that it was. Just not getting our questions answered. I think the place I'd really like to get to before we go to sleep, we have like 250 puzzles in the Yanko list, and we should try to complete them. I was looking at this a little bit more. How about these two? Skip this one and do this one. We're sort of forcing this to be one wide if it extends. And we're also forcing this one to be one wide. Well, this will be one high and this will be one wide if you want. There's no way to do the, so yeah. So stay with me. We'll do this in a different color. If we went like so, notice how each one of these chocolate bars, these can't be joined right here. We've sort of eliminated one. And how do we get 3 more out of this chocolate bar? We can't have these 3 because they would go around the corner. So we would have to do this one, and then that would cause a contradiction. Therefore, we have to color in this one down here. Okay. Then we're stuck in a situation that's it's happening kind of because these are so close to each other. Hypothesize again. Suppose that we went like so. Fill in this. We definitely couldn't have this one. That would go around a corner. But we could use some more of these. We probably have to, we couldn't do all 3 because that would make a bendy shape up here. Take this one. Now we can't take both of these. Take this one. And we can't lengthen it this way, so we have to go like so. It's not impossible. You know, clearly that fits fairly well, but then we get up to this place and we're like, well, we can't take these 3, we have to take this one. Well, maybe we could take those 3, but we'd have to fill in all of this area right here. Well, I guess if you take these 3 and you have to take this one, then that's too many. We can't take those 3, we'd have to take this. Have to fill in these 2 to keep rectangling. And then we still need to get 2 more out of this. They can't be these 2, we'd have to take this one. Then we have to take this one. There's a couple ways to get 2 out of this top one. This bar along here, or this bar along the top. But if it is this bar along the top, then we'd have to take these 3, and that won't work. So we would be forced over here. If we didn't take these 2, then we'd have to take So we have to either take 2 or none because this bar is too wide and it's next to it. If we didn't take these 2, we have to take all 3 of these, and that doesn't work. We're forced to do this. Can't take this one. We have to do one of these. I don't think we can't extend to either one. We can't do another row of this bar because this one is either these 2 or these 2. And that would be the wrong width for our chocolate bar. We definitely can't extend this any further. We might be able to do this one and this, or possibly these 2. But we're getting kind of squeezed on this bar over here before. We could take all of these over here. Oops. If we took all of this chunk right here, that would leave us take 4 here, and these would be empty. We take one more here. It's vacuously. Oh no, wait, no, that doesn't work because we don't have. These would be empty, and these would also be empty. So we can't make this our 4, right? We have to take at least one over here. But then there's no way to keep it from connecting to this chocolate bar, I don't think. Not in a sort of rectangular way. We could take 2 over here, maybe 2 over here. That's about the best we could do. I think this might be the only way to do it with what we've got going right now. This the dot that we put on this 3 would be free. Would be our choice. We couldn't put these down and then let this bar interact. We couldn't put these 2 down. Couldn't put one of these. Yeah, I think we're stuck. I think there's no way to get a workable solution out of the remaining cells in this 4. So we were able to go fairly far from just this dot. And this is a kind of interesting puzzle because of that. Because we're having to deal with the implications of something that happened over here and then stretched across the board. That is my kind of puzzle, you bet. But look how long of a hypothesis we're unwinding here. If we believe all that, it was necessarily implied, which I kind of do, and we're here. We did all that just to color in this square. Okay. Let's check again. So a day or 2 ago, I was having a lot of happy vibes because I felt like we were making a lot of progress. It was operating without me in the middle, and now I'm pinging it to like check its mail and stuff. So highs and lows for sure. Did you turn it on and off again? Did you check your email? Oh. It seems like receiving email, as I said earlier in the day, it should be sort of an event driven thing with consequences. It's only reading the last 18 lines. I'm kind of curious what's underneath this. I'm in the wrong window. Okay, refinery 9-inch. Singleton per rig. Entirely at the pack level. Okay, so that's really the only way to go get the refinery. That sounds fine. Both. It seems like it could have figured out that I wanted to spend more time. Or just like it could have been reading while I was, thinking. All right. So at this point, these two would be connected. I guess I'm seeing that happen on the face of anything that's sort of multi-width. Is that we're causing things to be connected? Then if this one is connected, it's sort of like these are go together too, but if we color in this, then we can't color in this one or any of these. We have to color in all three of these. We have to color in this one can't be colored in. We definitely can't use all three of these. We could use at most one. And then we might be stuck just sending our chocolate across like this. We couldn't use these three. We would probably have to, I don't know. It is a lot to keep track of, and it's hard to keep track of all the relationships at once, I think, or all of the different hypotheses and possibilities that we're doing. You can just kind of continue along with this, like keeping in mind that this is like a sort of second level hypothesis, right? Last time we did get something out of constraining this for. It has to either continue this chocolate bar or stop it, right? So certainly if it's filled in at 2 by 2, there's lots of stuff that we can't do. Like we can't do all 4 of these because that makes a weird bulbous shape. We can't do 2 of these and 2 of these because that again makes a bulbous shape. We can't do 3 of them. There's no way to get 3 out of a 4 square. We probably have to continue this 3, get this 1, and then put 1 somewhere else. Starting to think that the density of this area too most constrained area. Maybe we didn't look at it in enough detail. Try this one. Keeping in mind that now we're not going to be able to connect this up because that would create a weird shape. And same on this one. If we took this one, then it would have to continue down this way. So we could take this one, but then we have to not take this one or this one. We have to take all three of these. I guess one more question. We're talking about re-implementing our version of the refinery. But what would we get? Stalling the gas town. Would it interfere too much with our design? Are they compatible? And I think this is also my sign. I'm flagging a little bit, of course, but maybe what we need to really do is deep dive the pack API now. I think that we're sort of asking the Oracle to answer the wrong questions a little bit, or we should have our own intuitions about which packs we should be using, what not to use, how to implement our stuff in terms of packs, meaning like plug-in agents and formulas, that kind of thing. How do we learn what's out in the community, that kind of thing. I'm not sure this hypothesis is taking us fast enough toward where we want to go. Maybe it's a simpler hypothesis to consider if we just fill in this or not. Let's try that one. If we fill in one, we've definitely got to do the other one. And we'd have to do this one too. We have an option to extend it, but we definitely can't extend it to like 3 by 4. That would take up too many cells in this 4. If we extended it out to 3, we'd only have used 2 cells here. But then there's this problem of where to put the last 2 cells for the 4. They'd have to go like here and here. Pretty sure. We can try that hypothesis real fast. Here. Here. So this is, if we extend all the way out to 3, yeah, we can't extend any further. We have to skip all of this. We have to take these 3. And then we have to take only one of these. So you can see that that makes an incompatible shape. That doesn't work. So expanding it out to 3 wide is no good. we can still look at 2 wide, but since expanding out to 3 wide is no good, we can cross out all of this. Now these are all linked, and they're all in or out, and they all have to be in. This one's out, so this is out. Out, 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 in. And we still need to get 3 out of this. But they can't be these 3 because that would make a funky shape out of all of this that we can't recover from. So it would have to be these 3. That makes another funky shape that we can't recover from. So I conclude that we actually cannot fill in these. So this is empty, empty, empty. And that's interesting. It means, I guess, we can only continue the 4 by going down this way with these 2. We still have 2 more to assign. Okay. An alternative is that we slightly redefine the roles in our system too. For instance, as I mentioned, let's pretend that we adopt their whole system, but we have an org coordinator that does some of the things you've been doing. My understanding is that the mayor, the gas town pack, is flexible like you and does the most cognitively heavy work. We have assigned you some tasks. But we add or assign that to its mayor. Or assign and we have assigned you some heavy lifting tasks, but it's less that it is specific to your role and more that you can do things that you can do any job. guess I'm not totally explaining what I'm thinking about this, but the and it's an artifact of being tired too. But the idea that you can't assign him that job, it's a mayor, and that mayor is a workflow coordinator. This is definitely like my mayor has been a workflow coordinator as well. We're using slightly different terminology, and the jargon is kind of helpful because we can build up a shared understanding and not get it too confused with the concepts. But yeah. Let's see if it accepts that. Yes, one mayor is much like another, which is something I believe to be true, but I'm not totally sure. Hmm. I really feel like the two worlds we've got going are this one. This one is the world of one wide chocolate bars, or one high, if you want. I guess you might be able to extend this one over this way. We might be able to make this a 3 by 3 chocolate bar. But if we did, we definitely have to take out these three. We'd be left with both of these two. If we made this a 2 wide chocolate bar, certainly can't go 3 wide. There's no way. If it were the 2 wide chocolate bar, oh, and it does have to be extended at least a little bit. There's no way to get around that with the configuration that we have on this, because we can only drop at most one of these. So we can't take this one and not this one. They're together. They both have to be used. We have to heal this notch in our chocolate bar. This. No getting around any of this. Then we got to make this weird shape here. So I would say that's eliminated too. Oh yeah, we've been really forced into coloring like this. This. I think we're going to be forced again. We certainly can't color in this one. We need to get 2 more out of this. We can't color in these 2. Got to be this one then. And it's Buddy. This is a slow going inference package here. I think we're learning things about sides of chocolate bars. But yeah. If we extended this up here, we would have to use these 3. And we'd have to heal that notch right here. And we'd have to figure out how to... I don't think that would work. Because we have to get 3 out of this somehow. We get 2 to extend this chocolate bar, but then there's nowhere to put the 3rd one. And if we don't put those 2, then we get a weird shape. So I think that one actually doesn't work. We can't extend these 2. got to go this way. I'm not drawing out all of my hypotheses, but there you go. Certainly can't do all three of these, so we got to do this one. If we did all three of these, we wouldn't be able to extend up here because this is kind of in the way. And that would mean all of these would get taken out and there wouldn't be enough cells. So we can't take all three of these. We have to take this one. Now these two are linked. Either both or neither. If we did take this one, we definitely have to fill in here. I mentioned before that if we took both of these, that there's no way to finish off this 3 section. Because it's either both of these or none. So we don't take them. We have to do this. Have to do this. We can not take these two. Both, because that causes a weird shape. So we do have to take both of these too. We're getting kind of constrained by there only being 4 cells to put 3 chocolates in. Oh, we healed our bar. And then we stop right there. Okay, now we need to get 4 out of this. We can do it like so with these 2 and these 2. Or we can do 3 and 1. I don't see another way to do it. We certainly can't do 1 and 3. So we have to fill in this one. Three and 1, or 2 and 2. So these are both getting colored in either scenario. 2 and 2. This is also getting filled in. Okay. We're not sure yet if it's this one or this one. They both kind of work. We're still not sure which one of these we're filling in the 1. And then we've got to get 4 out of here. These ones don't match up, for sure. So we can't do both of these. Do at most one of them. We could do 2 here and 2 here. Oh, but we can't do 2 here because only one of these columns is going to be used. So it's at most one of these, at most one of these. We can't do 2 of these. That makes a weird shape. So at most one of these. That means we'd have to do this one and have to do this one. If all of my logic is sound, and I think it is. Cool. If we did this one, we'd have to take out these 3. Then we'd have to make a weird shape. So we can't do this one. We gotta do this one. We still got to get 3 cells out of here. We can't do both of these. We got to do one of these. This turned into a both or none. If it is none, then it would be a weird shape. So it has to be both. And we've got one more to get. Since we can't extend this chocolate bar now, gotta be these. And if we're gonna do one more here, then it's gotta be right here. Okay. Can't make a weird shape, and there you go. I think this is their solution. I didn't. I sort of referenced it as I was thinking. Yep, this little diagonal thing, this in the corner. That was a hard puzzle. Man, that was hard. Sure. So it thinks it's a real mayor. I think routing, dispatching, and planning is cool. Hmm. Hmm. Um. Yeah, if we can. Yes. Let's let's explore those concepts. It's somewhat. Let's explore those concepts with GC Oracle. I'll also take a look at the documentation tomorrow to see if we can understand facts. Let's say deep dive. So packs. There's a chance. There's a chance we're disagreeing about labels. We're disagreeing about labels. Polecats are kind of raw power on low cognitive tasks, and that wouldn't hurt for some of our jobs now and in the future. Of our jobs now and in the future. There's also a chance we are we could gain from adopting a system that has been explored by the wider city community. We might be able to set up some appropriate experiments to see how their system works. I like I like the idea of librarian, archivist to understand business processes. Although this might be more of a universal that every one of our departments needs within your scope. Understand your standard business processes and prefer them to ad hoc whenever they apply. I find this statement's really funny, right? Charters are things that we invented. It doesn't have that necessarily defined scope. Mayor might have a defined scope, or it might be the most flexible agent, as I mentioned. More of a universal tool. Decentralizing is an important aspect of the department's philosophy. Okay. As you said, I don't think that we want to get rid of everything we worked on. But getting the Gastown mayor to adopt it might be best of both worlds. Let's see from the Oracle how hard it is to integrate our hard one lessons with this community. Okay, well, it's starting to get a little bit snippy. I find it funny, of course, if that's really what's going on. You know, it has some pride of place, and I think let's leave it in a cliffhanger to see how it reacts to all of this. Fascinating, right? Now, we started our own city in Tutor to kind of it is named after a tutorial, right? We were doing the tutorials at first, and then we were trying to take this and take it for a spin. So certainly one direction for the series might be to try the Gastown pack and see the pros and cons of it compared to this approach that we have kind of invented out of our heads. But yeah, like I said, marrying the best of both worlds is kind of the goal. Perhaps creating the design pack is an important goal. Um, Decentralizing might be an important goal. Giving the gift of decentralization to the community might be a possibility. But yeah, I guess we'll see how that goes. Certainly, I'm getting a lot of personal juice out of applying all of the stuff that we're doing to the business problem that I'm interested in. But we could kind of pick any business problem. Perhaps one more remunerative or you know heavily demanded by the current state of the industry. We'll see. Yeah, it's a late one, so I hope you're doing okay. Be well. We'll see you tomorrow.